Welcome to Cranbrook Institute of Science's day one of our Rouge River Water Festival. We're really happy to see you guys. Today we're learning about where we find the water on our planet, how much of that water we can actually use, and how our water travels throughout our planet in all of its different forms. So when we are talking about water, the very first thing that we need to understand, we need to know, is how much of the earth is actually covered in water compared to how much of our earth is covered in land. So I'm going to ask you a couple times throughout our presentation here to answer a question for me. And to do so, we are going to use the poll feature. So this will allow me to give you some options and you can kind of choose them as far as multiple choice goes. So for this first question, I'm going to open up this poll and I want you to click on the percent of the earth you think is covered in water. Okay? So that should be open up for you. I'll give you about a minute. I'm going to give you just a little bit more time here. Let's see if we can get everybody answering this question. So, what percent of the earth is covered in water? About 20 more seconds to answer this if you haven't yet. Alright, so 5, 4, 3, 2, 1. Alright, I'm going to go ahead and I'm going to close that poll and we're going to see what we think. So it looks like, it's kind of funny, 71% of you think that 71% of the earth is covered in water. We had 14% say 65% of the planet is covered in water. About 4% of you thought 22% of our planet is covered in water, and about 14% thought 66% of our planet is covered in water. 71% of you got this one correct. So 71% of our planet is covered in water. If we look at our globe here, okay, we can see there's a lot more blue than there is any of the other colors. So 71% water, 29% land. That's about 3 times more water than there is land on our planet. So water is very, very important to our planet. There is quite a bit of it. If all of this water though, it's not the same kind of water, right? So we have 2 major types of water on our planet. We have our salt water and we have our fresh water. And we're going to look at kind of which of those we have more of and kind of where we find all of that water. So I have a container here. We're going to say that the water in this container represents all of the water on our planet. Okay? If I open this up, I'm going to pour a little bit of this water out into my cup here. The water that's remaining in this container is going to represent our salt water. So this will be the water that's in our oceans. All of the salt water on our planet is left in this container. The water that's in this little cup here that I poured out is going to represent all of the fresh water on our planet. So if we compare these two, we can see there is quite a bit more salt water than there is fresh water, right? In fact, 97% of the water on our planet is going to be salt water, and only 3% of our planet's water is going to be fresh water. I'm going to set my salt water aside. Think about this fresh water is, even though we can say we have this much fresh water on our planet, About 2% of all the water on our planet, so most of what's in this cup, is going to be found in a form or in a location that we actually can't get to or can't use on our planet. So one of the locations on our planet where we would find water that we cannot use would be the water that we find frozen in our glaciers or in our polar ice caps. Because of the fact that this water is frozen and because of the places where we find glaciers and polar ice caps, we can't use that water to do the things we use fresh water for every day, right? We can't shower with glacier water. So I'm going to pour that water out of my cup since we can't use it. And I'm going to set it to the side. Right? That leaves us with a little bit less fresh water in our cup. We can't use all of this. Some of this is also going to be found very, very, very deep underground, inaccessible to us, a place we cannot get to. So we use groundwater every day, but we use the groundwater that's right below the surface of our earth. We dig wells down into the surface, we draw that water up. Pretty easy to get to. Water that's very, very deep underground, it's too far for us to reach, so I'm going to get rid of that as well. I'm going to set that aside with the rest of our water. Finally, some of the fresh water remaining in this cup is going to be found in our atmosphere in the form of water vapor. We can't use water vapor. Water vapor is a gas instead of a liquid. So I am also going to get rid of our water vapor contained in this cup. Okay. That is going to leave me with this tiny bit of fresh water. This fresh water in this cup represents our reachable groundwater and our surface water on our planet. Things like lakes, rivers, streams, ponds, all of the surface water that we utilize for our drinking water, for the water we use in our homes, the water we cook with, the water we clean with, that's all contained in this little teeny amount here. That's not a lot of water for everybody on our planet to share, right? So it's important to understand how that water is moving around, where it's going, how it's changing forms, which is what we're going to talk about when we start to talk about our water cycle. A fun fact about fresh water in the state of Michigan is 20% of the world's fresh water is contained in our Great Lakes. So we are in a very kind of lucky position here where we're surrounded by a lot of our planet's fresh water. It makes it a good place for us to live. So when we're talking about our water cycle, we're going to move on to talk about our water cycle, do a little demonstration here. But it's really important to remember that even though our water doesn't always our water isn't staying in the same place or staying in the same form, we're always going to have about the same amount of fresh water, 3%, and about the same amount of salt water, 97%, on our planet. It's just moving around. So we're going to create our own mini water cycle here. I am going to turn on another camera here. So hopefully you'll be able to see this a little bit more up close. So you should kind of have a view of a container there. This is going to be our mini water cycle. So the first thing I'll do is I'm going to pour some very, very hot water into the bottom of this container. In this case, we're using electricity to heat up our water. But as far as the water cycle goes, out in nature, out in the real world, our sun would be our heat source, warming up our lakes, our rivers, our streams, heating our surface water. So I'm gonna grab that hot water. And I'm going to pour some of that into the bottom of my container here. I'm going to let a little bit more of it heat up. So the water in the bottom bottom of this container, that's going to represent our surface water. That's our usable fresh water like we talked about, right? Our lakes, our rivers, and our streams. When a body of water, like a lake, a river, or stream, absorbs enough of that solar radiation from the sun, it's going to start to heat up. Some of that liquid water is going to turn into a gas, and it's going to rise into the atmosphere. This process is called evaporation, and it's pretty hard to see. So I'm going to add a little bit more hot water to this in a second, but we're not going to be able to really see that evaporation taking place. We will know it's happening though, based on some of the other processes that we'll see occur in our little water cycle demonstration. So, a little bit more hot water. If my water got hot enough. We'll see what happens. But keep heating up. Sorry, my water isn't getting hot for some reason, but I'll add some more in just a second. But what I'm going to do next, and what we'll see happening, is I'm putting this plastic wrap over the top of our container. I'm going to add ice to it in just a couple of seconds. Oh, look, we've got something going now. We're good. But this plastic wrap with the ice on top of it, so I'm going to put some ice cubes. This is going to represent our atmosphere. So as we move away from the surface of our planet, we move up into our atmosphere, the temperature of the air is going to start decreasing. It's going to start getting colder. That's why we have the ice. And as the temperature gets colder, the water vapor that's rising into our atmosphere is also going to cool down. That means that that water that we find in a gas form, it's going to start to turn back into a liquid. Tiny drops of liquid are going to start forming from that water vapor, and these water droplets become kind of sticky. They start to stick to each other. They stick to particles of dust in the atmosphere, and this is how our clouds form. This process is called condensation. We can see that condensation start to happen in our model here. So the sides of our container started to fog up as soon as we put this plastic wrap over the top. We're also going to see condensation forming on the underside of the plastic wrap that's covering the top of our model here. I am going to add a little bit more hot water to hopefully speed this process up here. It should be very hot now. Can see even after, right after we added that, the sides of our container are starting to fog up quite a bit more. So we have that process of condensation happening. As we kind of finish up talking about this, I want you to keep an eye on what's going on with the sides, the condensation on the sides of this container, because we should start to see the next step of our water cycle occurring. So once enough of those water droplets have stuck to each other, they're going to start to get heavier and heavier inside of our clouds. Once they get heavy enough, gravity is going to take over, and those water droplets are going to fall from the clouds. That process is called precipitation. So that's when liquid water falls from the clouds, we have rain. When water falls from the clouds and it freezes on the way down, or it's frozen before it falls, we're going to get our other types of precipitation like snow, sleet, and hail. So if we look kind of closely at our model here, what we should see is that some of the condensation on the sides of our container and on the underneath of our plastic wrap are going to start, we're going to see some water droplets falling. It's kind of hard to see because the sides of our container are foggy, But a good thing to look for is if we see the water moving in the bottom of the container, that means that we have water droplets falling, that rain is occurring. Think of like a ripple in a pond. Okay? So kind of give it a second. I've seen a couple drops, but it's not moving super fast.
For those who are joining late, please turn off your video.
And for anybody that's joining in now or that's joined later, just a reminder to please keep your video turned off. That way we only have the demo in the window. Make it a lot easier for everybody. Okay? So we're seeing what you can definitely see. You look in the side, the view of just the container. Along the walls of our container, we can definitely see some of our precipitation starting to happen. We have those distinct water droplets forming. So we should be able to see our water cycle kind of going through the processes of the water cycle. So our water cycle is happening all across our planet. Our water cycle is always happening. It's happening to our salt water, it's happening to our fresh water, and the amount that's in each of those places is always kind of staying the same. So we have similar amounts all the time. It's just the individual droplets of water that are going through the process. So one of the big questions after we talk about the water cycle, one of the things we really need to think about is if we can ever make more water. Can we create more water? Does water get created through the process of the water cycle? Is water a renewable resource that we can make more of? Things like trees are a renewable resource because we can grow more. Or is it a non-renewable resource like our fossil fuels? And we can't create more water to refill the water that we've used. And the answer to that is that we can't create more water. The amount of water that we have on our planet right now is the same as it was when the dinosaurs were around. It's the same as it will be hundreds of years from now, which makes it even more important to understand how our water moves, what's going on with our water cycle, what's going on with all of our water processes on the planet, so that we can protect this resource that everybody on our planet needs in order to survive. All living things on our planet need in order to survive. So we'll continue to learn about freshwater and to talk about freshwater and how to protect it the rest of the week through our other programs. Before we wrap up for today, I had some questions submitted from some students. No? We had some questions submitted from some students. They might not be on this call, but they're still really good questions that go along with this program to answer. So the first question was, how did salt get into our ocean? Or how does salt get into our ocean water? Why are oceans salty? And most of the ocean salt comes from rocks on the surface of our planet. So when it rains, the rainwater breaks down those rocks, and the particles get washed into our oceans. A big chunk of that is salt, and that salt builds up in our oceans, so we get salty ocean waters. We also get salt in our oceans through underwater volcanic eruptions. So that's what makes our ocean salty. And the second part of that question was, is there a way to make ocean water drinkable by removing the salt? So kind of goes with that question, can we create fresh water even if we can't create water in general on our planet? And the answer to that is we can remove salt water through a process called desalination. But right now there's not a method to do that that's cheap enough, fast enough, or produces enough fresh water for it to really be a useful thing to do on a large scale to get people fresh water. So both those were really good questions, kind of go along with what we're talking about, and we'll be answering more questions about freshwater as we continue on with our programs throughout the week. So thank you all for joining us, and we hope to see you later in